Have you ever just, stopped and wondered about the absolute magic that brings this whole digital world right to your screen? Well, today, we're going to pull back the curtain and demystify that entire process. Let's get into it and find out how the internet really works. I mean, really think about it. The information you're seeing right now, it traveled from a server probably thousands of miles away and just poof, landed on your device in less than a second. How on earth is that possible? It feels like some kind of sci-fi stuff, but it's actually a story of some seriously incredible engineering.
Okay, so let's kick things off by busting the single biggest myth out there. When you picture data just zipping across the planet, it's so easy to imagine it beaming down from satellites up in space.
And it kind of makes sense, right? I mean, we use satellites for GPS, for TV, so why not the internet? You figure a signal goes up from some data center, bounces off a satellite, and comes right down to you. It's a nice, clean, simple idea, but nope, it's not how the vast majority of our internet actually works.
And here's the main problem. Just pure, raw distance. A communication satellite? It's parked way up there, about 22,000 miles above us. So for a signal to get from a server to you, it has to travel all the way up and then all the way back down. You're looking at a round trip of 44,000 miles.
That enormous distance creates a really noticeable delay, or what the engineers call latency. And for things like streaming this, or playing an online game, or being on a video call, that kind of lag is just a total deal breaker. The whole experience would be painfully slow.
So if our data isn't being beamed down from space, then where is it coming from? Well, the answer is actually a lot closer to home. In fact, it's right under our feet.
That's right. The internet isn't some invisible, mysterious cloud. It is a massive, tangible, physical network of cables that are crisscrossing the entire globe. So let's take a look at this physical backbone.
This is the real backbone of the internet. All of this data, it starts on a server in some huge data center. From there, it dives into a global network of fiber optic cables. We're talking about hundreds of thousands of miles of these cables, some of them no thicker than a garden hose, just laid out on the ocean floor by special ships, physically wiring continents together. It is an absolutely mind-blowing feat of engineering.
Okay, so we've got this gigantic web of cables. But how does a little piece of data that starts in, say, California, know how to find your specific phone in Tokyo? Well, it needs an address.
Every single device that connects to the internet, your phone, your laptop, even the server holding this information, each one has a unique IP address. And you should think of it exactly like the shipping address for your house. It's just a string of numbers that tells the network exactly where to send the mail.
Now here's the thing. Computers, they love these numbers. But for us humans, we're awful at remembering them. Can you even imagine having to type in a long string of digits every single time you wanted to go to your favorite website? No way. We needed a much friendlier system.
And that's where the DNS swoops in to save the day. The domain name system is, for all intents and purposes, the internet's giant phone book. It has one simple but absolutely vital job. It translates the human-friendly names we type, like youtube.com, into the computer-friendly IP addresses that the network actually needs.
And the wild part is, this whole thing happens in a fraction of a second. You type a name, your browser pings a DNS server for the IP address, the server sends it right back, and boom, your browser connects. It all happens instantly. It's simple, it's fast, and it's honestly pretty elegant.
All right, so we've got the route and we've got the address. Now, how does the actual data get sent? It doesn't get sent all in one giant blob. That would be super inefficient.
Instead, the server takes that huge file and it chops it up into thousands and thousands of tiny, manageable little chunks called packets. By breaking it down like this, the network can move the data around so much more efficiently and reliably. It's really one of the most brilliant ideas behind how the internet actually functions.
And each one of these packets is like a tiny digital postcard. It's got a little piece of the data, of course, but just as important, it also has the destination IP address, where it's going, and a sequence number, which is crucial so your device knows how to put all the postcards back together in the right order. And get this, the packets don't even have to travel together. Each one is on its own, independently finding the best and fastest path through the network, almost like tiny little cars navigating around digital traffic jams and congestion. It makes the whole system incredibly resilient and super efficient. So once all these little packets start showing up at your device, and they might even arrive out of order, your computer or your phone just uses those little sequence numbers to perfectly reassemble them, just like a jigsaw puzzle, creating the seamless content you're watching right now.
And if any packets get lost along the way, your device just sends a quick message back asking for them to be resent.
Okay, so the packets have crossed oceans and continents. They're so close. Now we just have to cover that very last crucial step, getting from that huge global network into your home and onto your actual screen.
This is the final critical translation. The data comes into your house as pulses of light, zipping through a fiber optic cable, and your router, its main job is to be the translator. It takes those light signals and converts them into electrical signals for a wired connection or into radio waves for your Wi-Fi. It's the little box that bridges the massive global network to your personal one.
So let's just quickly recap this amazing journey. Our data started as a file on a server. It cleverly avoided that super slow detour through space. Instead, it traveled as pulses of light through a physical web of undersea cables. The Internet's phone book, the DNS, gave it the right address. It got split into thousands of tiny packets for an efficient trip, and then it was all perfectly put back together on your device just for you.
So after all that, what's the most important thing to take away from this? It's that we really need to change how we picture the internet. It's not some fluffy, weightless cloud. It's a real, physical, tangible network. A much better way to think about it, it's an ocean with massive currents of data flowing through deep-sea cables.
And that incredible physical journey, a journey of light and logic, is happening right now. Every single time you click a link, stream a show, or search for an answer. All of it moving at impossible speeds right under our oceans and our streets. It's the hidden, physical system that truly connects every one of us. Thanks for exploring it with me.